It's really great to be back here. I always love coming here. See new faces and old faces and connect with people and hear people's suggestions about ways we can improve our products. So if you have any suggestions, please come talk to us. I've been doing RAID software for 20 years, actually more than 20 years, 25 years. And every time I talk about software RAID or SoftRAID to a new person, a lot of times people go, wait a minute, hardware RAID is so much better. And I feel like I should write a blog post about it because it comes up so often. And what's really, the arguments I have are, first of all, the very high end is software RAID. Backblaze, all software RAID. There's sort of a middle ground where people are using hardware RAID controllers, and the low end is like the free products are software RAID. But when you think about it, your RAID controller is not built on the same type of 3-nanometer process that Apple processors are built on. It's got much less memory, the memory bandwidth is less, and the way that all the hardware RAID vendors get performance, at least with RAID 4 and 5 and 6 and 6 Plus, is they have a huge RAM cache, and they dump everything into the RAM cache as you're writing, and then they sort of spool it out and do the write calculation and write out to disk afterwards. And that's great unless you lose power. And if you lose power, that 4 or 8 or 16 gigabytes is gone. So we have a much more conservative approach. We use like around 100 megabytes of kernel memory for our cache. When you're doing like 20 gigabytes a second or 10 gigabytes a second, that you blast through that 100 megabytes really quickly. So there's not a lot of stuff that stays in that cache. So there's some other major advantages for software RAID, and they are things like there's no hardware dependence. You can take a SoftRAID volume, for instance, that you created on, or that was on a 2010 Mac 10 Pro Tower. You can take those drives out and plug them into one of our Thunder Bays, and the volume will just mount. It just works. In fact, you can take volume created with the very first version of SoftRAID for macOS 10 and plug it into our current product, and it will just mount. So we're really conservative about on-disk formats, and we want people to be compatible. We want people to keep using old hardware if they want to, or if it's an archive that gets stuck somewhere and you want to bring it back online. We want to not force you to upgrade your hardware, and we want to not require you to have one of our enclosures. You should just be able to move your disks around. We also have now, in this past year, our SoftRAID for Windows product has reached feature parity with SoftRAID for Mac. So the same features work on both platforms. We have higher performance than hardware RAID, and I'll show you that in a minute. We use very little of the CPU when we're doing the most CPU-intensive operation is writing for RAID 5 and 4 volumes because you're doing the parity calculation. We actually use very little CPU bandwidth for that, and I'll show you that as well. And we have really good disk drive monitoring. So SoftRAID for Mac and SoftRAID for Windows. You can actually take a SoftRAID for Windows machine, an installation, and you can create a RAID 4 or 5, 1 plus 0, RAID 1 or RAID 0 volume, and you can just move it onto the macOS. And the reason this works is because SoftRAID for Windows comes with its own macOS extended and APFS driver. So if you make a volume on Windows or a Mac, you can move it to Windows and it will just read and write just fine. And the SoftRAID for Mac product knows when you've got Paragon's NTFS for Mac are installed, and it will allow you to create an NTFS volume on your Mac and read and write to it, and then you can move it to Windows. So this is like when you've got a large project and you want to move it to another workstation. Say you're doing color grading and you've already done your editing, and you want to do the cross-platform thing without having to set up a NAS that'll allow you to move 100 terabytes back and forth. You can just unplug the box and plug it in. So let's talk a little bit about performance. This is our Excelsior 8M2 card. It's a PCI Gen 4 card, has 8 blades on it. When we first shipped it, there was no PCI Gen 4 Mac, so we were seeing about 12 gigabytes a second. And then when Apple shipped the 2023 Mac Pro, which supports PCI Gen 5, we all of a sudden started seeing double that performance. So this is on the right is the RAID 0 performance. Oh, sorry, on the left is RAID 0. On the right is RAID 5. So you can see we're doing over 20 gigabytes a second on RAID 0. And when we were first shipping NVMe solutions, everyone was doing RAID 0. They wanted the fastest performance. And now that we've got such good performance, people are starting to use RAID 5 on NVMe. And you'd say, OK, well, how much CPU bandwidth this is taking? And you'll see that we're using 9% of the system, the total CPU capacity for doing reads and writes. In actual fact, of this 9%, 3% is the SoftRAID driver doing the parity calculation, and the other 6% is APFS making space for this data that's coming in at 10 gigabytes a second, and the NVMe driver that's handling all the IOs that are going down to the drives. NVMe, unlike SATA, the maximum transfer size is 16 megabytes. NVMe is only 1 megabyte. So there's a lot of hand-holding that has to happen in the driver between memory and the actual NVMe device. So likewise, we have a 8-drive SATA box called the Flex 8, Thunder Bay Flex 8. This is the performance we get with 8 SATA drives in RAID 0 and RAID 5. It's roughly comparable to what you're going to get with a hardware RAID box before you exhaust their cache. So this is done with a 64 gigabyte file size. Some of our competition, they'll do maybe a little faster than this for writing to RAID 5 for the first 4 gigabytes, and then it steps down. So with this situation, we're only using 2% of total CPU bandwidth for doing writes. So we're just barely using any of it. People are like, they're worried about GPU usage, CPU usage. It's really a non-issue, you know, even on the really high-performance cards. So let's talk about predicting disk drive failure. You know, it's really great if you're working on a project to know that your disk drive is highly likely to fail rather than it's already failed. And in 2010, I ran across this study that Google did in 2007. What they did was they looked at 100,000 disk drives in their pool, and they captured all the smart data every 24 hours. Now, this is not the smart test. This is like smart parameters. How many hours has the drive been on? How hot is it? How many errors does this have? How many reallocated sectors? And they looked for when a drive disappeared in the pool, and this was 2 engineers in Mountain View. They have their servers all over the world. They contacted the person in charge of that server module, and they said, okay, did you take that drive offline for some reason, like the server module failed, or was it because the drive failed? And if it was a drive failure, they went back in time and they said, is there an event that happened in the smart data beforehand that is predictive, that has a correlation? And what they found were the 3 smart parameters that were highly predictive of a hard drive failing. And they were the number of reallocated sectors, the number of unreliable sectors, which are ones that are reading but not the data coming off isn't quite as intense as it should be, and then end-to-end errors. And if any one of these counters went from 0 to 1 or to some other higher number, the drive was 20 to 60 times more likely to fail in the next 2 months. So we incorporated this into SoftRAID. We've been having it, you know, for years and years. And I really wanted to do something other than just SATA drives. So I decided that we were going to do the engineering work to support NVMe blades. And we now support, as of SoftRAID 8, we support predicting failure on NVMe blades. I think this is really exciting. We actually will predict failure on your internal storage on your MacBook Pro because the MacBook Pro is NVMe. On the Mac Pro, it's a different architecture, so we don't actually have visibility into that. We used to support Smart on USB 3 drives. Because of Apple's driver architecture, that stopped working with 10.14. I'm hoping that Apple is going to provide us the infrastructure we need to bring that back, and I'm hoping that we'll be shipping that a year from now. So we have a way of, as every other software product does, we have an opt-in for anonymous user tracking. We have 10,000 people opted in. Of those, 6,000 are using macOS 14. The really surprising thing I found when I prepared for this talk was almost 10% of those people have had a predicted to fail drive, a drive that they've been using that we flagged as predicted to fail. So I was surprised because I didn't expect it to be that high, but it really shows you that this is allowing a lot of people who are using our storage to figure out that a drive is going to go and to actually be able to schedule when they're going to do a drive replacement. So these drives are not, they're still reading and writing data. Sometimes they're slower. Some drives I've seen have like 20 or 30,000 reallocated sectors. As you use them, they'll reallocate like 10 or 20 an hour. These drives are obviously really sick, right? And we have a few people who are saying, oh, you're just imagining it, I don't trust you. And then usually 2 or 3 months later, they come back to us and say, yeah, the drive actually failed. But this allows you to say, if you're in the middle of a project, you can say, okay, I know I'm going to risk it for the next week, and then I have a weekend, and I can do the drive swap and do the rebuild. And it doesn't become a catastrophic thing where you have a drive failure right in the wrong moment. So as I said before, I've been working on SoftRAID for years. We started in 2003 with just RAID 0 and 1, and then we added RAID 4, 5, and 1+0 in 2014. The major change that happened over those years is Apple started to get really to prioritize anti-malware protection, or protection against malware, and that took the form of making it harder and harder to get a driver to load. So when the Apple Silicon Macs came out, in order to load our driver, you had to boot into recovery mode, and then you had to reduce security, which meant that it sounded really scary. You're reducing security. It was actually, you couldn't load any software that didn't come directly from Apple. Software still had to be notarized, it still had to be signed, but it couldn't, it was a scary step. So I went to Apple and I said, look, this is really not working for us. It's not the Mac solution. It's not simple plug and play. And they came up with a suggested solution to them. And they said, no, that's way too much work for us. Instead, what we'll do is we'll put your driver in with the Apple drivers. So starting in 13.3, our driver is now inside the system folder. It gets installed as part of macOS. It gets included in your signed system volume, and you can never get rid of it. It's just there. And it loads only when there's a SoftRAID volume there, so it's not like running all the time, but it is part of the blessed Apple software. It's not Apple software, it's our software, but it's treated the same way. So the end result is, after 13.3, you can take any SoftRAID disks and plug them in, and our driver loads. This has, of course, required us to have to really increase our game on both testing and debugging and qualification of new features. We've gotten much more conservative about introducing code changes. We have a much more aggressive code review policy now. So in the last year, we've gone from SoftRAID 7.6 to SoftRAID 8.3. And there are many, it looks like, oh, there's a little minor change. But actually, we have been working really hard on this. And there are several really major changes we've made. The first was there's a type of register in processors called SIMD, and a type of instruction. It's a single instruction, multiple data. And it's where you can pack multiple data things into one really long register and then do a math operation on it and then unpack it. So rather than doing our parity calculation 64 bits at a time, we could do it 128 bits at a time or 256 bits at a time, and in theory, use 1/4 the number of cycles. And I was really excited about this. I got hired a really bright intern, and I had him working all last summer on it. He kept like doing tests, and we kept like trying to figure out, okay, can we prefetch data? You know, before we actually need it in the instruction, there's a prefetch, like on Intel, there's a way to prefetch data and get it into the processor's cache. We worked really hard on it, and we just didn't see any difference. It's like, what the hell's going on? You know, why are we not seeing any difference? So I realized that the ARM processors are so good at fetching data and so good at prefetching. They sort of have a way of figuring out that you're in a tight loop and you're doing things over and over again, and they automatically reach out and get that data. And we were actually memory bandwidth limited in this step. But in the process, I looked at the way we were threading our driver and the way we were doing the parity calculation. And it used to be that we take every I/O, every large I/O, and divide it up into blocks, and we give this block to this processor, this block to this processor, this block to this processor, et cetera, and we, in theory, have them all going in parallel. And this was, I was like, oh, really proud of having designed this, you know, back when it first shipped. And lo and behold, I think what's going on is one processor does some work, and the other processor's cache notices there's a difference and has to grab the data and bring it over. Because when I turned it so that we were using one processor for each I/O, we got a dramatic decrease in the amount of CPU we're using, and we got an increase in speed. It's totally counterintuitive. Now keep in mind that on macOS you're running multiple I/Os at one time, so I can have one processor doing one I/O, another processor doing a second I/O, and the third processor doing a third I/O. So we're still doing things simultaneously, it's just not, we're sharing them on each I/O. So I was really excited about this. This is what brought us the really low CPU utilization we have now, and also took us from 7 gigabytes a second writing to RAID 5 to 9 gigabytes a second. The other thing I wanted to do in moving forward with this Apple relationship is be able to script testing over a long period of time. So we now have a scripting environment that we use for testing, and if our tester in type A finds a problem, he can just write a script using a scripting environment, send it to us, we can determine that that is a problem, and then send the script to Apple, and then they can reproduce it. It saves a whole bunch of going back and forth about, I can't reproduce this problem. You can just send them the script and tell them to plug it in and run it, and it works. We also are using this now for doing very long duration testing. Our standard test now is 6 to 8 days. It tests all the RAID levels. It tests data corruption. It tests for kernel panics. It tests a regular volume and also a degraded volume that's missing one disk. This test is so rigorous that with macOS 14 and our old driver, the SoftRAID 8 driver, we could not make it succeed. It would fail every time. And now with all the work we've done with both with Apple with macOS 15 and with SoftRAID version 8.3, we can now run this test and work all the way through. To give you an idea of how much I/O it's doing, when we use our Thunderbolt 8 X8, which I have on the outside, it's a Thunderbolt NVMe storage device with 8 blades in it. It will do over 2 petabytes of transfers and 30 billion I/Os. Okay, this is like a 30th of the lifespan of the blade. Like I could run this test 30 times and the blades would be gone. Like, so my boss basically yelled at me with the first time I ran it, and I told him, and I said, look, we need to know this is reliable. Some bugs show up only after you've done like 4 days of really intense testing. So now we're really confident that we're hitting that quality level. The other thing I noticed was that we don't get a lot of people reporting kernel panics, but everyone who gets a kernel panic, it's really, going to ruin their day, right? So we have this technology we have called tech support reports. When someone contacts us and says, hey, I've got a problem, we ask them to generate a tech support report. It grabs all the information from all their disks and volumes, but it also grabs the kernel panics. And so even if they're calling us for a problem with a license, or hey, I don't know how to do this thing, we get the tech support report in from them, and we have a pool of them, and then I had someone this spring mine those for kernel panic information. And so we just include the panic information from people running macOS 14 out of these 1,000 people, and this is what we found. So this is the percentage of all the people getting kernel panics, not the percentage of all people, thank God. But it's really interesting because we looked and we were able to find general classes of problems. Like the watchdog timeout is when the Windows server doesn't check in with the kernel, and after 120 seconds, like 2 minutes, the kernel goes, oh, there's something really badly wrong, and it panics the system. The Dart kernel panic right here is it's something that's been on Apple Silicon machines since the beginning of time. We have been reporting it for 3.5 years. Every year, Apple says they fixed it. At first, they couldn't reproduce it, so we were actually sending them hardware that reproduced it. We did what's called a hardware capture, where we got a machine and a storage device from a customer and hand carried it down to Apple so they could reproduce it. I'm pretty confident. So anyway, this is only Apple Silicon Macs. Some of the other things, sleep transitions and the hot restart, are both power manager issues. These two here only happen with HFS extended volumes. They have nothing to do with SoftRAID. The sleep ones have nothing to do with SoftRAID. Anyway, so we could look at the panic logs and figure out whether this was an Apple kernel bug or our bug. And what we found was 3 of them were our bugs. And the rest were Apple bugs. So we're working with Apple to try and get them to address these issues. It's really hard when you've got someone who's like 4,000 miles away from you who sees something once every 3 weeks to get that information to Apple. So we're working on ways to get that to be better. This is the status right now. So we fixed 2 of the 3 of our bugs. The fixes are in SoftRAID 8.3, which comes with macOS 15. The last one only happens when a drive is really sick. And my other engineer is working on this right now. It will be in the 8.5 driver that will ship in the spring. And we're working with Apple to try and get them to fix other ones, especially the watchdog kernel panic bug. The top 5 are the ones that I really want to get fixed. They're the ones that people are seeing. Again, people don't necessarily call us and complain about them. They may have had their machine all of a sudden restart sometime 4 months ago, but they still show up in our tech support report. So we have a fix for a problem that we saw with degraded volumes on RAID 4 and 5 volumes on NVMe storage. It is also in the 8.3 driver. We saw like a few bytes being corrupted on a degraded RAID 4 or 5 volume. And if you're using NVMe RAID 4 or 5, please upgrade to macOS 15. Or if you're on macOS 13.2 or earlier, please just upgrade to SoftRAID 8.3, and it will automatically install the new driver. So I'm really in favor of macOS 15. It's the first OS that's come out where I actually want to upgrade and start using it straight away. I've always upgraded my phone as soon as the new OS came out in the fall. I've always waited for until the spring to upgrade to macOS. I accidentally upgraded to 14.1, and I thought, oh my God, it's stable. I can use it. And with macOS 15, I would have no problem upgrading to macOS 15 today. I think it's really reliable, with the exception of some issues around this machine right here. So if you've got a Mac Pro with NVMe blades, and you upgrade to macOS 14, you probably ran into the problem where you would boot up and your and your blades wouldn't be there. You could see the card and system profiler, but you couldn't see the blades. What happened? Where did they go? So it turned out there was a bug that got introduced in macOS 14. We hand-carried hardware to Apple so they could reproduce the issue. They got the fix in. The fix is in macOS 15. So if you're running Mac, if you have this hardware configuration, please upgrade now. You'll save yourself some pain. On the other hand, with HDDs, SATA HDDs, there's a kernel panic bug. We caught it. We didn't catch it in time for Apple to fix it. So if you're running with an external enclosure with SATA HDDs or SSDs, please don't upgrade. Just wait. It's probably going to be sometime between now and Christmas that they fix it. So I'm really excited to be here. I always love being here. We have many new things coming in this current year. I can't talk about them at the moment, but I'm going to be so excited to see you next year. Thank you very much.